try it. Video 232. Normally I just go with small mistakes, but if they're big I start over, and I've made 2 big ones already and I'm in a bad mood, so hopefully this goes better. So 232, what we're looking to do is we are looking to make proofs or flowcharts based on triangle similarity. So we're going to go through, we're going to determine if these triangles are similar. If they are, we're either going to make a flowchart or a proof. I'll probably make both at the beginning for the first 1 or 2, and then from there you guys choose which one you want. Later in the year I'll be formally introducing proofs, and then we'll all be doing proofs at that point, but for now a flowchart is going to be fine. So when I look at this one, it's kind of an interesting problem here because it gives me 3 sides here and 2 sides here and 1 angle. So I can try and because it's a right triangle, I can use the Pythagorean theorem and find this missing side right here and shoot for side, but it'll just be faster to get rid of this side and try and prove side angle side, because whether or not they're similar won't matter either way, so I'll just take a shortcut. So what I'm going to do here is I am going to try and figure out, hey, are these things in ratio? So if I go HI, that's going to be the big side here. It's going to equal 16. And I'm going to compare that to the big leg here, which is JL. And that's going to be 12. So what I'm going to see there, my ratio is 4 to 3. I hope we get that. 4 goes into 16 4 times. It goes into 12 3 times. So I have that side ratio. I know that these angles are the same, right? I know that angle H is congruent to angle L because that's given to me. But what I don't know is, how about the small sides? Is side HG? I know it goes comparison to side LK, right? Again, the 12s don't necessarily match up. The big sides match up and the small sides match up. So I get 12 over 9, and look at that. If I divide 3 into 12, I get 4, and I get 3 into 9, I get 3. So we do have the same ratio. So if we look here, I am going to be able to prove this with side angle side. Because I have the same scale factor. Now the question is, how did I know these sides are the same? And the answer is a little bit weird. It's because I did math. You could also say calculation or computation. But I didn't know just by looking at them that 16 and 12 and 12, 9 were the same ratio. I actually had to calculate those. The angles I knew just by looking at them, though, because they were given. They were given with those ticks there. Those marks. So now what I'll do, it doesn't matter how I start my first triangle. Like I said, I'll just say HIG. And again, you'll notice I use the similar sign. I'm not using the congruent sign. I'm using the similar sign because we're proving similarity, not congruence. Goes to triangle. Well, H is the 90-degree angle, so L is the 90-degree angle. I is the angle across from the small side, so I'll take J, because J is across from the small side, and then G is across from the big side, and K is across from the big side. So there we go. I have proved these triangles are similar because of side angle side similarity. And like I said, if you wanted to, you could have done the same thing with a proof. And a proof, you have the fact here and the evidence here. And what I would have said is HI over JL, which is 16 over 12, which is 4 over 3 because of math. I would have said angle H is congruent to angle L because of given. I would have said HG over LK is the same as 12 over 9, which is 4 over 3 because of math. All right, I could number these if I wanted to. And then finally, I have proven that triangle HIG is similar. I'm running out of room here. HIG is similar to triangle, I'll do this, get myself a little more room, to LJK because of side angle side similarity. So you can see they have all the same information. It doesn't matter which way you want to do that there. All right, let's go to B. What does B look like? When I look at B, I am going to obviously go for side, side, side if I can. So I think the easiest way to start with the big one. Sometimes I like to just look for an obvious scale factor. So I know that here I have 14 over 7, which is 2 over 1, which means if I go to the small side, I should get 8 over 4. which is 2 over 1. And at this point, a lot of people just assume, all right, well, these triangles are similar, but we have to prove all 3 sides. So that last side would be the 9 and the 5. And that is clearly not 2 over 1, right? That's not true. So on this one, we would say it's not similar. Again, you got to be real careful. You got to do all 3 sides. Let me pause for a second and set up the next video. I got to be honest with you, C is a little bit tricky. So there's a couple different ways that we can do this, but I think I mentioned in a previous video, I always encourage my students when it looks like this, when they're overlapping, a lot of times kids just have trouble seeing them. So I would suggest you break them apart. And I think that way makes it a little bit easier to see. So if I break that up into VTM and I break this up into SMN, and I want to point something out real quickly. Do you notice that these are both, like that small triangle and that big triangle, these are both M. So even though I moved them apart from each other, I know that these are the same. I don't want to forget that this angle is the same in the small triangle as it is the big one. A lot of times kids can kind of forget that when you break them apart. But let's look at the lengths here. Well, this one will be easy. I know SM is 9, and I know NM is 11. The big one here, I know it's 9 plus 2.5, so it's going to equal 11.5. The problem is I have no idea what this length is. I have no idea what this length is, right? I don't know what that is, and I don't know what this is. But look what I do know. I do know that these angles are the same. So, man, look at that. It looks like it wants us to do a lot of bit of math and stuff, but we just have angle-angle similarity. So this is going to be a pretty easy one after all. It looks kind of tricky, but not so much. So the first one I'm going to do is I'm going to say, I know that angle M is congruent to angle M, and I know that's true because of it's the same angle, right? That's actually known as the reflexive property. Hopefully you guys spent some time on that in junior high and in integrated 1. We'll definitely spend some time on it this year as we get into more proofs kind of stuff. So, but that's what we have there. And then the next one is I know I can call this angle V, but I can't call this angle S. I can call this angle V because it's the only angle there, but angle S has a couple of angles there. So just because I'm going to use 3 letters here, I'll use 3 letters here. So I'll say angle TVM, and again, hopefully we remember how to name these things from integrated 1, right? TVM, we want that middle to be the vertex, right? That's got to be the case there, so be real careful with that. And I know that that's congruent to angle, and again, my vertex is S, so the S has got to be in the middle. It can be NSM or MSN. It doesn't matter. But what is important is that that vertex is in the middle, and I know that's true because they gave me that with the ticks. Right? Again, I filled this tick in myself. I realized that it was the same one. So there we go. That's how easy this is. I'm going to say triangle VMT. I'll go to the big triangle. You can see I made a mistake there. Is similar to triangle. The V goes with the S. The M goes with the M. So that must be the T goes with the N. And I know that's true because of angle-angle similarity. I will pause again to set up the next problem. For the diagrams in 290, find the missing lengths if you can. So no problem on JK. We had already discussed that this was the Pythagorean theorem. So what I can do is say that I'll just call this side x. I'll say 9 squared plus 12 squared is equal to x squared. 81 plus 144 is equal to x squared. 225 equals x squared. I'll take the square root of both sides. Again, hopefully we're comfortable with the Pythagorean theorem. It's a big deal, so if you don't know it, you're going to want to learn it for sure this year. So 15 equals x. So I know that this equals 15. So JK equals 15. Now can I solve what the length of VT is? I don't know that I can. I know these things are in proportion, but I don't know what this is so that I can use my scale factor to solve this. So I have no idea what that is. So I'm going to say I can't solve VT, but TN I actually can solve because I know I have this ratio. The small triangle is 9, and I can compare that to the big triangle, which is 11.5. And I'll set that up to the small triangle, which is 11, and I'll compare that to the big triangle. I'll just call this part x, right? NT I'll call x, so that's going to equal 11 plus x. So I hope you guys see what I did there. Again, let me kind of clear this off so you can see. I want to say one more time. The small triangle is 9, but the big one is 9 plus 2.5, which is 11.5. This is going to be 11. Small is 11, but the big is 11 plus x. Here I can combine 9 and 2.5 and get 11.5, but here I cannot combine. So I will cross multiply, and I'm going to get 9 times 11 plus x is equal to 11.5 times 11. I've got 99 plus 9x is equal to, I have no idea what 11.5 times 11 is. Is equal to 126.5. I will subtract 99 from each side. So 9x will equal 27.5. I'll divide by 9. And whatever 27.5 divided by 9 is, 3.05 repeating. So actually I'll just put that there. So there you go. That is the answer. So kind of a weird one there, but that's what we come up with. All right, so 292. Okay, so 292, it says, Cameroon offers you a challenge. Are the triangles at the right similar? How do you know? So let's see here. Yeah, I don't know that they're similar. Look there. We talked about this at the beginning of 231. If the scale factor is 1, they're not similar. They're congruent. So are they similar? I mean, similar is congruent, but I'm going to say no. So it says use a flowchart to organize. We would obviously do side angle side, but our scale factor would be 1. So these triangles aren't dissimilar, they're congruent. Is Cameron correct? Yes, there's a scale factor of 1. And then it says, so write a conjecture. So our conjecture, which we've already talked about this in our notes of 231. So if similar triangles have a scale factor of, typing is hard, of 1, the triangles are congruent. And then it says use an arrow diagram. Now that you have proved this conjecture, you can use this arrow. Yeah, we had already discussed this. I don't want to spend too much time on this. I hope you guys understand. I know I didn't do a lot of what this problem asked, but I just feel like it's redundant to what we're already doing. So let me pause and set up 293, and then we will end this video. All right, so there's a lot going on problem 293. It says, first of all, are these triangles similar? If so, make a flowchart. Or I guess we could make a proof if we wanted to. So first of all, I'm going to go back to something we learned a while ago, which is that the smaller angle has to go with the smaller side. So we know that this triangle is more than 90 degrees. So this one, if I have, this is 90 plus 47, that's 133. 137, that would make this 143. So this has got to be the smallest angle. I don't know what that angle is, but I know it has to be the smallest. And that's important because this one also has to be the smallest. Because everything has to correspond. So I know that N goes with T, I know that U goes with A, and I know that R goes with C, right? So just in terms of like biggest and smallest. So I already have an angle. I already know that these angles go together. I already know that they correspond. So now what I need to do is prove the sides that are next to them. So I would have to prove that 8.4 goes with 4.2, which gives me 2 over 1. And I would have to prove that 16.4 goes with 8.2. and it's also 2 over 1. So there you go. Yeah, I would say these triangles are similar. So yes, we know they're similar because of side angle side similarity. So I'm going to go ahead and see if I can squeeze this in and finish this one. As a matter of fact, I can tighten this up here and maybe do a little bit. So first of all, I know that RU, side RU, is going to match up with side CA, and I'm going to get that scale factor of 2 over 1 because I did math. I know that angle R is congruent to angle C. I know that because it's given. And then now what I can do is I can go ahead in here and I can say 16.4, which is RN, is going to match up with CT, which is 16.4 over 8.2. Again, I know that because of math. And because of that, I can do my triangle similarity statement. I'll say RUN is similar to triangle. And again, we know that R goes with C. I know that U is the bigger angle, so A is the bigger angle. And I know that N is the smallest angle, so that T has to be the smallest angle. And I prove that using side angle side similarity. All right, it says Charles has cat goes with run as the conclusion in his flowchart. Lisa has NRU is similar to TCA. Who's correct? Well, cat and run is what we have. But let's see here. N should match up with the T. It's in the third spot. R should match up with the C, same spot. U should match up with the A, same spot. So they're both correct. Who's correct? Both? Because there's multiple ways to write this correctly. Multiple correct answers. So hopefully you remember that as well. I know we've talked about that quite a bit in integrated 1 and integrated 2. It says, are cat and run congruent? No, they're not congruent. How do I know? Because they're not the same size, right? They're similar. So I'll say no, not congruent, different sizes. And it says determine all the missing side lengths and angle measures of this. So that's kind of interesting. Since we know that they are similar, that means I can go back and use my proportions and ratios and what I know about these things. So first of all, we know that these angles have to match. So this must be 103 degrees and this must be 43 degrees, right? And this must be 43 degrees. Oh wait, it's not 43 degrees. I'm sorry. The math on that. This would be 150 degrees, so this would be 30 degrees. And this would be 30 degrees. I was saying the biggest it could be was 43. So my mistake on that. All right, so we used the triangle angle sum theorem, the fact that triangles add up to 180 degrees to calculate those sides. And then we know our scale factor. So if I take this side and cut it in half, I get this. If I take this side and cut it in half, I get this. So I just need to cut 12.3 in half to get this, which is 6.15. So there we go. Finish that section. Hopefully you guys were able to follow along. If not, feel free to reach out and ask some questions.